Hello everybody, today we'll be revising Thevenin's theorem. By definition, any combination of power supplies and linear components can be replaced by a single ideal voltage source and a single ideal resistor. Thevenin's theorem is used to simplify more complicated circuits. The end result is a circuit overhit. The key terms that you need to know and calculate are the open circuit voltage, the short circuit current, and the equivalent resistor. In an example, a voltage divider such as this one, where R1 equals 1.9 kiloohms, R2 equals 2.4 kiloohms, and 9 volts is the input voltage. To figure out our first term, VOC, we need to say that the output current is 0. This means that we can now use Vout equals Vin R2 R1 plus R2 formula, and we can fill out the values as they are. So input voltage 9 times R2 2.4 kiloohms over 1.9 kiloohms plus 2.4 kiloohms. If you plug that into your calculator, you should get 5.023 to 3 decimal places voltage. The next thing we need to calculate is the short circuit current. To do this, we need to only investigate the first resistor. And to do that, we will now completely shun R2 and connect the output voltage to 0. So now the circuit is drawn simply like Vin and 0 volts. And we want to figure out the current that is being drawn in to that resistor, and to do that we can use our Ohm's law formula, V equals IR. So I, to rearrange for I, simply divide by R. Now we can fill out our values. So actually this will be Vin and this will be R1 as left by our new drawing. And if you put that value into your calculator, you will get 4.737 milliamps to 3 decimal places. Finally, to calculate the equivalent resistance, we need to use our two previously calculated values in an Ohm's law equation. So V equals IR. We want to figure out R, so we divide by I. Essentially, the equivalent resistance is the open circuit voltage divided by the short circuit current. If we fill out our calculated values of 5.023, 4.737 times 10 to the minus 3, even better if you could save the values from previously and simply input them without rounding. And you should get 1.06 kilo ohms to 2 decimal places. Now if we redraw the circuit, we will have the open circuit voltage, which was 5.023 volts, our equivalent resistance of 1.06 kilo ohms, and that's it. Exactly the way it was before. Here is now here. You've calculated your Thevenin's theorem.